Okay, so here's a quick little video I thought I'd make about this switch out of a toaster. I was kind of inspired by the really bad quality mains cable that I burnt out earlier, and this itself also failed in quite a spectacular fashion, although it wasn't because of its bad quality or anything. It was just worn out from years of use. But the failure mode could probably have been prevented with a different design, I think. So in a sense, this probably isn't as good as it could have been. But yeah, anyway, so this is the switch out of a standard electric 2-slice toaster, and I imagine you'd get the same ones in a 4-slice and all that. But this switch has the two contacts at the bottom here, where the mains cord connects in. You've got live here and neutral here. And then these outputs here go to the heater and the timer circuitry and all that. So normally, now this one is obviously broken. Normally we have two springy sort of contacts of copper that come down from these 2 points here and sit normally like this, and when this piece of plastic gets pulled down, they move up and touch the contacts down here. You can see this one's broken off and it's stuck on here, so you can get some sort of idea of what's happened. But basically, normally this sits upright in the toaster, and when you press the lever to turn the toaster on, this has a little metal spring steel sort of thing coming out from here normally. So when you press the lever down, obviously it pulls down the like the lift thing that takes the bread down, so that goes down, and it actuates this, which then gets pulled down as well by way of the spring steel thing that sticks out here normally, and then that will pull this down, and this bit of plastic here will obviously pull these contacts out and touch them onto these contacts here, and then we get a full circuit through both sides of the switch. Live and neutral both then go straight through and go to the circuitry, so that's what's supposed to happen. And in addition to that, I've just got a timer board from another toaster here. So in addition to that, we do have the timer circuit. I guess this uses some sort of probably a binary counter or something with an oscillator in it, and it just switches this electromagnet here, which is kind of half of an EI lamination transformer. It's just got one winding though, and this on the carriage thing with the lever that pulls the bread down, you also have the other side of this electromagnet, the kind of I side. This is the E, it looks like a capital letter E, and the other side is an I. So that comes down and goes on here. So at the same time that the top half of this sort of transformer core touches here, this will get engaged with power. The winding on this will get power to it, and it'll create a magnetic field that holds the top half to this bottom half, and at the same time this comes on, so it's got power. And then the timer runs, and when the timer runs out, depending on what you've set it to, this coil then loses power, probably switched by this transistor or something. And then the coil obviously lets go, and the toast carriage thing flies up because it's got a spring on it, and that then disengages the switch at the same time, and then everything's powered off and everything resets back to the default state until you put more bread in and push the lever down again. But basically what's happened here is, after several years of use, and I had repaired this before actually, because the little spring steel bit that came out here that goes under the lever that you push down, that had actually snapped off about a month after the warranty expired. Funny that. So I replaced that with like a piece of a hair clip thing, and had it screwed on here, because I had a little rivet that went through this hole, but I didn't have a rivet, so I just used a screw and nut, a little M3 screw I think, or M2 maybe, I'm not sure. Anyway, and that worked fine for another couple of years, until basically one day pressed it and there was just a big flash and a bang, and everything was dead. So what actually happened was you've probably figured out by now, but like I said, these two contacts are permanently connected across live and neutral. These are the outputs. This particular one here had actually snapped off, as you can see, and it's fallen down, and when the lever's been pushed, it's just been directly, this strip of copper has basically just been shoved straight over the live and neutral terminals, and it's created a dead short across the power cord. This contact here wasn't snapped off. That actually snapped off as I took the switch out, and when I was replacing it with a new switch. So that wasn't actually disconnected, but it was its end part was what created the final contact between this strip came down to about here, and the other one sort of welded between these two, but it broke off easier as I was sort of undoing everything and taking this old switch out. So as you can see, it's not the best design, I would say, because it's sort of inherently it is kind of bad, because these contacts here obviously will flex back and forth over time and eventually snap off, I guess, as this one had. I don't think these things are really designed to last a huge amount of time. They've just sort of simplified the design to the cheapest sort of thing they can get. I mean, typically with previous toasters, I've noticed the heating elements usually wear out after about a year or two. They usually just break somewhere, and then you just have to get a new toaster. But like I said, this one, the little actuator on this did break just after the warranty period, which is quite amusing and not necessarily surprising. But yeah, considering that the elements hadn't broken and I was able to fix the switch possibly was being used for longer than it should have, and these eventually just snapped off, because this one was weakened quite a bit and this one did snap off originally. So I'm kind of thinking, this thing does sit upright, and the way this works, I mean, it's kind of inevitable, or not necessarily inevitable, but it's more likely due to the design that if the switch does wear out and one of these contacts snaps off, it could well just fall down onto the two live contacts, basically, which is not very good. So I think it should be a different design, possibly in terms of safety, so that this, if these do snap off, maybe have it up the other way or something, so that the live connectors, the live terminals are at the top, and if the contacts break off, they'll just fall down out of the way, and instead of falling onto live contacts there, it just seems like a kind of a bad idea, or have it sideways, or just a completely different design altogether. I do imagine that you could probably replace this switch. Well, I think you could replace the switch with a relay, basically, and then have the instead of this actuator here, you could probably mount like some sort of button switch, maybe underneath where the lever comes down, or some sort of thing like that, and then have that power up a relay coil instead, and then the relay switches the contacts. So you'd have to have a relay that was with a coil that was rated for your mains voltage in your country, and the contacts obviously would have to support enough current for the toaster element and everything. But I think that would be a much safer design. I mean, they obviously don't use that because it's going to be more expensive. They've just simplified it down to this single sort of custom designed switch thing. But yeah, I mean, it's not a great design, because these contacts can, and obviously in this case did, fall down and short directly across the mains input, so it's not a very good design. But I do expect that they probably predict that the heating element, or the little spring that comes out here, will break before this wears out, so that's probably what they're counting on. But yeah, so as you can see in this photo here, I was able to repair the toaster with a new switch that I'd scavenged out of another one, which is where I got that other timer board from. And I had to make my own, had to again rebuild the actuator spring thing with a hair clip, because it was the wrong shape and length. So I just made my own and screwed it on and everything, and it works fine, it's still going. So it'll be interesting to see how long that lasts, whether the switch breaks again, or it's the heating element that wears out next time, or what. But yeah, it's that's a failure of a toaster switch and how you can repair it. You can scavenge one out of another toaster. I did have to do some modifications also to the bottom part where it mounted, because say for example on this one the mounting screws were here, and with the other one these terminals actually had a hole underneath, so they were quite exposed, and the mounting screws were in different locations. So I also had to get a blank bit of PCB material. I just took this, this one has copper obviously. I used a piece that had no copper on either side, and I screwed that to the bottom of the new switch and used that as a sort of insulating plate to make sure that these terminals, because otherwise they'd be very, very close to the chassis of the toaster, and that wasn't very good. So something to watch out for. But if you can't get a new switch, I imagine you could easily, or fairly easily, just replace it with a relay and a button to switch the relay coil. I suppose you'd have to figure out some way of mounting the switch underneath the lever, the toast carriage lever thing, but other than that I expect it would probably work quite well. But yeah, there you go, a failed switch out of a toaster, and you can see it is quite nicely burnt and melted in there. I'm going to see if I can focus on that. You can see where it's welded itself across there, and all the black soot on the inside of the switch. So yeah, it's done quite a good job of making a dead short across the line, and it blew the fuse in the meter box. So that was quite amusing. But yeah, not much else to say really. But yeah, I think these could probably have a safer design than one that is more likely for the contacts to break off and fall down onto live contacts, rather than if it was up the other way and you had the possibility of the contacts breaking off, then they'd just fall down onto the bottom of the toaster rather than falling onto live metal, which doesn't seem very good. But yeah, anyway, that's that. So yeah, not much else to say. See you next time.